Hello, my name is Scott. Welcome back to Adrenaline Fueled Firearms. Today we're going to talk very specifically about building AR-15s, specifically the component known as the upper receiver assembly. What we have here is the components for a complete AR-15 upper receiver assembly. This one to be chambered in 6.8 SPC2 with a barrel and a 1-to-10 twist. Now YouTube won't let us show the steps in assembly or a lot of other details that you need to be aware of, but what I want to do is just go through very basic mechanical concepts, inspection, and what comes after your planning phase. Once you've decided what caliber, what barrel length, what other specifications are going to go into the build that you want to do, we're going to talk about the individual components and how to double check them and look at them and be sure that you have what you need and that you should be able to safely assemble it and utilize this firearm in the end. So we'll start off kind of from bottom towards the top. You're going to need your tools. Some of the tools I have laid out here are not out of a basic armorer's kit. Some of them are tools that I've acquired over the years, but most of them did come out of a Wheeler firearms gunsmithing kit. That's a very basic kit, and it came with the mat, which honestly, the mat, I think, especially for a beginner, is kind of an important piece, because sadly the mat does lay out all the individual components so that when you decide you want to build this, A, you'll have a majority of the tools available inside the kit, but B, the kit itself also comes with a tool that some people might not see as a tool because it's just the mat. But in fact, this specific tool will allow you to look at it and go, okay, this is a view of all the individual components that go into the creation of this firearm. I need to be sure I have these components ordered and available for my build. Once you have all your components, inspection and test fitting are both very important steps. I was a mechanic for a long time, and a majority of the mistakes I saw that were made by people who lacked years of mechanical expertise were either trying to work on something without the proper tools, trying to work on something without all the proper components, or simply failure to properly inspect a component because you pull it out of the package and assume it's ready to go. And this is not always the case. I can't recall whether I mentioned it or not in an LR308 build video, but one of the items I purchased, one of the first reviews that I spotted that popped up, was an individual who obviously didn't have the mechanical experience and probably shouldn't have been assembling his own AR-10/LR308. His comment was that when he installed the barrel nut, it damaged his upper receiver because there were pieces of metal left in the inside of the barrel nut that damaged the threads. Okay. That right there is 100% why inspection and test fitting is very important. You can't assume that a component comes to you in perfect condition. You can't assume that there is no metal left from the manufacturing process and just ram it down. He pretty much literally took probably $20 or $30 barrel nut and ruined a $300 upper. It's just makes me insane on the OCD mechanic level, how some people make assumptions about things and then they leave a bad review on something which, yeah, it was an inexpensive component. But you wouldn't have had a problem if you'd taken 10 to 15 seconds, taken the component and gone, oh look, there are pieces of metal in here. Because I bought that exact reviewed component, and no joke, it had chunks of metal in it. And I just reached in there, popped the little pieces of metal out that had been, and it was an inexpensive product. It had been inexpensively machined, it had been treated, coated, and packaged. And I reached in there, I got the pieces of metal out that hadn't been completely removed before it was coated, and the minimal QC process that was done, it got through, and Merry Christmas. I used the exact component that had the exact problem, and I've been completely happy with my results on that item. As a matter of fact, I'm sub-MOA on that with a, crappy barrel nut that came with pieces of metal in it. So I stress research. When in the research phases, when you're deciding what you want to do, when you're deciding what you think you want to do, when you're looking at what other people have done, what they've done right and wrong, foundationally, research is important. Once you have laid that supremely important foundation of research, the next thing that I stress the most as being important is quality control and check the condition of your components and don't just ram something together. The fact of the matter is, yes, I ordered this barrel from a reputable barrel manufacturer. Yes, I have received barrels from this reputable barrel manufacturer in the past. Deadshot barrels, by the way. No, I have not received one that was improperly machined as far as the contour goes, which means the shape of the barrel itself is the contour. There are dozens and dozens of different contours that different companies will machine barrels to. That's part of your research. Just take my word for it. There's a ton of them out there. So I have not received any barrels that have been improperly contoured by Deadshot barrels. That doesn't mean that I do not go through and double check that there's no metal shavings, no damage here to the barrel extension, no serious mars or damage to the barrel itself, that the gas block has been machined to the incorrect size, or that my little magna ports were not machined properly and may have stray material in them. I mean, you can look at these here. You have 5 holes which are not really even aligned in a straight line. I mean, their magna port on their barrels is basically a free process when you're pricing their barrels. They don't match, they're not in a straight line, they're not real great. They exist. They have threading options and many other options. Go look at their website if you're interested in a Deadshot barrel. Google it, look it up, check them out, see what you do or don't like. Personally, I'm not a huge fan because of this barrel of their magna porting, because I've had 2 other barrels that I've bought from them and their magna ports were evenly spaced and level and look pretty good. These, you can tell, are not evenly spaced and they kind of zigzag along. So I had issues on the quality control side that I'm not going to make a big issue of with the manufacturer, because I don't think that nullifies the barrel itself. It's an appearance thing. I checked the journal here for the gas block. It is machined to 0.750 as was requested. So I'm going to go ahead with this build. But what I did do also, as I said, check the barrel extension, checked for debris in the barrel, checked for any damage during shipping that may have caused dings, dents, or mars here in the barrel extension area where it mates up to the upper, or any serious damage or mars where the gas block will go where it would affect sealing. I have made sure that I did have all my tools also. I add a tool to that does not come with the kit. This is a little gas block roll pin installation jig that comes with a little roll pin starter. And I still got 2 of the gas block roll pins, because I have tried to install roll pins into the gas blocks without any kind of jig to hold it in place while I put this little pin right here with the gas tube in there, and a line with the little tiny hole that goes through the gas tube, which is for the gas tube roll pin, which is right there. It goes all the way through, as opposed to the actual gas port, which only goes halfway through, which is right there. And oh my god, I bought 5, lost all 5 of them, tracked down another one, and then went to somebody who had the right tools and paid him a couple bucks and said, hey, hook me up, because I'm a dum-dum. So this is an add-on tool that's not included with the kit that I highly recommend you acquire, just to make it easier on yourself. I haven't used it yet, it's brand new, so I went ahead and bought 2 roll pins in addition to other roll pins that I've bought over time, because, well, I'm afraid I'll lose them. So you're also going to need or want certain chemicals. Now, some form of anti-seize for the threads for the barrel nut are very highly recommended. You're going to, of course, first inspect the barrel nut, as I've said. This is a internally threaded barrel nut, which I'll get into in a little bit with the Aero Precision. But you're going to want to anti-seize your threads so that later, if you decide to take it apart, it's not going to be like you're going to need an oxyacetylene torch to loosen it up before you even think about disassembling it. Use a copper or high temp or extreme high temp anti-seize. I don't honestly think manufacturer matters. This is basically the same style of anti-seize I utilized when working on M1 tanks. Their exhaust temperature is way higher than your firearm should ever see. So this was a pretty good anti-seize for what I used it for before, and this has been a pretty good anti-seize for firearms. If you want to pull it apart again. I mean, if you're one and done and never ever want to pull it apart again and never ever think you're going to use up the barrel and never ever think that anything's going to go down that you don't want it to loosen up, by all means, jam that sucker together with no anti-seize and keep it that way forever. I went with, as I said, I went with the Aero Precision, which is this is their enhanced upper. I like this personally because your handguard does not attach directly to the barrel nut, which holds the barrel in. To me, in theory, that I have yet to prove, but in theory, when you want precision out of it, it's going to work out better because your barrel nut is holding a solid part of the receiver, internally to externally threaded, castle nut torqued down, and the handguard is not affecting the barrel nut. There will be some minimal transfer through this thick flange of metal of motion of the handguard just because of metallurgy, but we're not even talking about thousandths. You know, I am not a mechanical engineer and I would not hazard to attempt to tell you what the difference between the two is, but there is definitely one. There has to be. I mean, it's a different system that I prefer, that I like for when I am building ARs. It's not to say it's the best, it's not to say it's the worst, and it's not to say that it's the only one that you could get. This is the one that I choose. Aero Precision includes their little, I assume you would probably still consider this a spanner wrench, but basically you take a 1/2 inch ratchet, attach it to this, and that's how you torque it down. When you do the final torque down, you're going to want to torque it down with an actual torque wrench, which I don't have in here because it kind of clutters up the space, I guess you could say. These are the basic tools you'll need. There are actual instructions online for how hard you should snug down without using a torque wrench. I tend to use one. I own one. I'm a mechanic. That was something I didn't have to buy. So, your barrel goes into the upper receiver, is tightened by the barrel nut. The gas block has the gas tube installed inside of it and secured in place with the roll pin. Is placed on the barrel, slides down the barrel, attaches to the bottom of the barrel, which brings us back to something I do like about dead shot barrels. They do put a little index hole for your gas tube screws. I built my 8.6 Blackout AR-10 with a Faxon barrel. Faxon does not do the indexing screw. Now, the indexing screw, to me, has two purposes. It helps you make sure that you are dead spot on Merry Christmas, because you are lining up a hole on the inside of the gas block that you can't see with a hole on the outside of the barrel assembly that you can't see. Since you're not Superman and you can't see the holes, it's a little bit difficult to get them exactly lined up. In the case, what you want to do is mark your barrel dead on exactly with a magic marker where that tube hole is. Your barrel extension retaining pin is also dead center. It goes into a notch, dead center in the top of the receiver. That's how it works. So the best way to tell where your gas tube is straight over with this. Make your mark here, install everything, get it all lined up as best you can, and then secure it. Now, the indexing hole, you torque the bolt down to the same specifications on both these Allens. However, obviously, one that's sitting inside a divot is going to hold just a little bit better. So, for instance, my dead shot barrel in 6.5 PRC, I have not shot the gas block loose on it. The gas block hasn't shifted, the gas block hasn't moved, and I've got more rounds through it. On the other hand, my Faxon barrel in 8.6, both of them have OdentWorks gas blocks. Both of them, I've adjusted the gas from minimum to maximum to find out what works best. Only one of the two has shot loose, and that is the one on the Faxon barrel with no indexing hole. Every other part of my procedure has worked exactly the same in both cases, except that difference in the manufacture of the barrel. So, you might want to research your barrel. You might want to think about having an indexing hole, if not for just the one reason of the fact it helps you index it, but the second reason it does hold more firmly in my experience. Once you've selected your caliber of your barrel needs to match the caliber of your bolt carrier group bolt face. Now you can purchase your bolt carrier group separate from the bolt face. Deadshot Barrels will sell you a bolt face that is already pre-head spaced to your barrel. I did not go that route here because I have the proper tools to check head space, and I went with a manufacturer's 6.8 SPC 224 Valkyrie complete bolt carrier group. I did not go with an adjustable gas block because I want to find out if I can get away with a dumb gas block that doesn't adjust. This is a carbine length gas system, so I have a carbine length gas tube. Now, at this point, this is literally my first AR-15 full build. Previously, I've done lowers and bought uppers and done some flip-flop, and I have swapped out some barrels and I've swapped out some handguards. But this is my first from-scratch AR-15 build. Not in my defense, but again, one of the reasons I always test fit is I got all my stuff ordered, I laid it all out, I did my basic inspection, checking for crap in the threads, crap floating in holes, crappy holes that didn't line up, slid it all together, and oh, wow, gee, there was a part somewhere that's supposed to be in here that's related to the operation of, oh yeah, the charging handle. So I had to go into my stores and find myself an old AR-15 charging handle that I'd marked in my spare parts bin. So, like I said, very important to lay out everything, make sure you have everything before you go to do your build. I talked about the anti-seize, I didn't talk about the thread locker because the thread locker is optional. Let's say that again. Actual thread Loctite is an optional chemical material to use in your build. I tend to use red and blue. I use the red around the barrel extension simply because this is manufactured by people who make barrels. This is manufactured by people who make a receiver. They're probably not completely 100% manufactured in-house, although in this case I believe that they are. However, their houses are in Washington and, oh crap, another state. They actually might both be in Washington, but the point is, the houses that these are manufactured in, when their in-house manufacturing takes place, are not the same house. Even if they were the same house, there's a reason Henry Ford made the F-wrench. Now, yes, machining processes have gotten much better since every nut and bolt came out a slightly different size. I get that. However, still, you're probably going to have 1/4 to 1/2 of a thousandth of difference between this surface and this surface inside here where it rests. Even if there is no difference initially, this is stainless steel, this is not. These two metals will expand and contract with temperature at different rates. The red Loctite is a more permanent adhesive, but in this case it's not being used as an adhesive. I'm using the paste because it's slightly thicker and it will help take up that fraction of a thousandth space to help keep everything just as firm and tight and locked in as possible, even through the expansions and contractions. Some people don't like it. It was recommended to me by someone who's built a hell of a lot more of these than I have, and my experience in reworking the stuff I've reworked has actually, no joke, had an effect on my actual accuracy. I'll go into that in a 350 Legend that I worked with and discuss exactly what my differences before I pulled it apart and when I put it back together were. I have all that data. So this time we're not going to get into it because I don't have data for this yet. It has not been assembled and shot, but I tend to use the red Loctite on the barrel extension in all my assemblies. The blue, well, it's blue Loctite. It doesn't have a hell of a lot of holding power, but it's better than nothing. And again, when we talk about expansion and contraction and different metals, heat, vibration, I mean, you name it, it's a firearm. It's going to get hot, it's going to cool down, it vibrates a lot. Yeah. These screws are not the same material that go into this construction of this upper. So metal to metal differences, throw a little blue in there, not a lot of blue in there, torque them down to standard specification. They tend to stay a lot better, in my experience. Anywhere where you are actually threading on a firearm, that is actually a threaded nut, bolt, screw attachment other than a roll pin, I will use a small amount of blue Loctite just to help hold everything together a little bit better and a little bit longer. Part of firearms maintenance is making sure that all your nuts, bolts, screws, and fasteners are still tight. And trust me, like I said with the 8.6, sometimes it only takes 5 or 6 rounds before something works its way loose. So maintenance is very important. So that is the handguard. That is the last component. It is held on by these 8 screws. They're offset on the upper receiver. The upper receiver came with the forward assist installed. You can get them without the forward assist. I'm old. The bolt carrier group has forward assist grooves. There are situations where a forward assist could be handy, and having that machined off makes it look all cool and slick and saves you, like, I don't know, 1.5 ounces. Yeah, personal preference. I also like the dust cover, just because, you know, dust cover. Dust bad, cover good. So that's really all we're going to go over in this portion. I will show you the finished product when we come back afterwards, because, as I said, YouTube will not allow us to show assembly. So thank you very much. I will see you guys in a few minutes if you're on YouTube, and possibly see you in less than a few minutes if you're not watching this on YouTube. Thanks a lot. I'll talk to you guys in a bit. Alright. All the YouTube people have shut it off. All the children have left the room. Everybody's gone to bed. Now it's adult, you know, true believer, real live, put it together time. So, what are we looking at here? We're looking at a pile of parts I've already discussed, a bunch of chemicals I've already discussed, and a bunch of tools I've already discussed. So, what are we going to do with them? Alright, well, here's what we're going to do with them. Step number 1, as I discussed, your barrel. So, we're going to get our barrel, and we are going to put some red Loctite on the barrel, and then we're going to insert it into the barrel receiver, the upper receiver. Here is where it rests. Here's from the back side with my big old long gnarly fingernail. So this area here is not a 100% glorious, gorgeous fit. So they slide together. It's not really a great way to show it, but I don't know if you can see the small amount of play that's in there. I don't have vice hands. There's a small amount of play in there. This is neither good nor bad. It simply is one metal machined at one factory being inserted into another piece of metal machined at a different factory. You've got, who knows, half a thousandth of difference between these two. So in order to compensate for that slight misfit, I'm going to take my red Loctite, make a couple passes with this thick red Loctite stick paste. Don't do what some of you did in kindergarten and eat this stuff. This is not like, you know, your kindergarten white paste. This is seriously going to have an effect on your system if you try chugging this stuff down. So don't eat this stuff. Follow all the safety warnings on the manufacturer's label, and generally try to be an adult and not eat crazy chemicals that you don't have any clue what's in them. And even if you do know what's in them, I'm pretty sure that this says don't eat it on it. So don't eat it. So I take a light coating of my red Loctite on these two flat surfaces that are going to be mated together. As I insert them, I'm careful to avoid the threads because I don't want Loctite in the threads. Now, I slide it in. As I slide it in, I turn it slowly so that it evenly distributes that red Loctite paste across the two mating surfaces. The number of rotations you make don't really matter. Just be sure you make at least one before you let it go all the way in and lock that barrel extension pin into place. Now, I'm going to demonstrate this again. There's still some play, but there's not quite as much play. So, in the end, because of the way the firearm is designed and the way the barrel nut functions, that play is going to be gone if you assemble this properly before you actually start putting rounds in the chamber or doing any other craziness with this firearm. So our next step, and you can see actually where a little bit of the coating when they applied it to the barrel nut didn't get evenly distributed. So there are acceptable imperfections in the components that we're going to slide with and call it good. So apply a moderately heavy coating of the high temp NECs to the barrel nut. Now you see why there's crap all over my mat, because I drop shit. So we'll apply a light coating of NECs here. This is the boring part. Maybe we'll edit this out. So like watching that guy on PBS paint. Some happy little clouds over here. A happy little barrel nut here with its NECs. So we're going to paint our happy little barrel nut with our NECs. There are jigs which you can purchase that work a little bit better than just standing here and holding this thing. And I am a cheapo. I have them. I don't have one set in my vise yet. So currently, we're just going to go with the old-fashioned do it by hand method. Run it down, let our barrel nut drop in. Clean the excess off our hands so we're not tracking any NECs all over everything. Now we're just going to gently thread this in. Now, as I said, I've already test fit this once. I've already threaded this together once, so I know that there was no metal components or damage to the threads during shipping or any other problems. It's just threads down nice and easy by hand. Doing each step initially nice and easy by hand can save you quite a few headaches when it comes to over tightening stuff and damaging it. So this is kind of a weird phase. I talk about doing a test fit and then a full assembly and a torque job and everything else. So what I always like to do first, because these chemicals can alter the spacing of your components, I always do a kind of a pre-torque test fit assembly, you could call it, which is where I actually put the unit together pretty much completely, but I don't have everything torqued and tightened down yet. Because what that enables me to do is change my mind, or if I have a problem somewhere where I fouled up and didn't assemble the unit in the correct order, gives me an opportunity to correct my problem and come back and do it properly. We're going to go ahead and go with the charging handle that I forgot last time. Insert it in here. Maybe. Are we going to have an issue? A little tight. Assemble it in accordance with the manual arms of the standard AR, just like we're just doing maintenance. These will shift during shipping, so you want to be sure that your bolt is forward in the bolt carrier group so that your pin here does not misalign and foul up on the inside of the firearm. That's our resistance from our dust cover. Slide it all the way in there. We're all the way forward. Forward assist does not get us any more motion. That means that it slid freely by hand completely into place, meaning that our headspace is not too big to seat up properly. Close the gas or close the dust cover because it will keep the bolt carrier group from falling out of here during handling and dropping to the floor and potentially damaging that component. Now we're going to try this. This could be a fun step because, as I said, I haven't done this before, but it seems to be self-explanatory, and I watched a YouTube video, so what could go wrong? I am going to remove my gas tube roll pin from its fine Midway USA package. I'm going to set my gas block, excuse me. Push my screws in so they don't foul on my jig. So thread our Allens in all the way. Lay this in the jig. It sits there pretty good. Now, this could be a lot of fun, or it could be a flipping nightmare. So we can look through and see that our hole lines up. So we'll hold this in our jig, get our pin in place, get our starter driver, get it past our big meaty fingers, promptly foul it up. Take our small hammer, get it started. Now, the saving grace of this bad boy. When you look at your gas tube must go upwards to get over the barrel nut. So it runs along the barrel, up, and then over the barrel nut, and ends up inside the bolt carrier group gas tube extension. So this needs to be in. You look down through the inside and see that the whole ports line up on the inside. Flip it over. Make sure that these holes line up somewhere. Interesting. Still big enough they line up. So we're going to look at it there. Get our hole lined up. Go all the way through it. Get it over here where I can actually get a hold of it. Look at it. So we've gotten the roll pin started, or we weren't lined up. Gently move the gas tube until it loosened up again. So now what we have is the pin is actually started into the hole in the gas tube. So it's holding itself in place. It's not so much of a wrestling match anymore. We confirm that it goes and arcs up, and that is at the top. So now we drive it home. I'm going to use their little starter again until it bottoms out, just because. I'll check it again as I go, make sure that I haven't knocked it out of alignment. As I said, this can be one of the more interesting stages of the process, and this is with the jig. Imagine trying to do this with just two hands and no jig. Now, it's a roll pin, so the reason I mention metal materials in assembly and manufacture, you can see where the metal of the gas block is actually scraping away some of the metal of the roll pin. Not necessarily an adverse bad thing. The roll pin is supposed to contract fully and allow you to press it in without losing any exterior metal, but you see the little gap in the gas tube roll pin has closed, but it's not quite got enough clearance. The reason I say this is neither technically bad or good is because when we're discussing this type of an assembly process, this gas tube roll pin wants to, needs to, should, must stay in there for everything to operate properly. Meaning, a little bit of metal sheared off on the outside hopefully means it's going to be tighter, last longer, and work better. If this went in too easily, I'd be a little suspicious of it. Now, we're going to skip part of this process. I'm going to finish driving this bad boy, and we're going to look at the next stage, which will be when we fit our handguard. And we want our handguard to slide snugly over onto the upper receiver, and for our bolts to line up. And that's what we get when we're right. All meets up here. All 8 of these holes line up. Should be able to simply insert the screws in there with some blue Loctite on them. Tighten down the handguard when it comes time for final assembly. So let's pause for a second. I'm going to finish with this roll pin, and I'll show you the rest. The roll pin is now driven into the gas block. As you can see, I have generously tested the quality of the nitride finish by banging it with my percussive device several times, and you can see how this lovely coating has for the most part stayed. Yeah, I gorillaed it. So, previously, in order to get into the block, I tightened down my Allens a little bit. I want to thread them back out so that they are clear of the bore. I am going to fully remove the back one, and I'm going to show you through the hole how nicely having a pilot hole in the gas block step on a barrel works out. So this slides down and then lines up there in the receiver. On this model, there's a lot of extra metal. On a standard receiver by most manufacturers, there's only a little hole basically right here. So we thread this through, we get this set in place, then we flip it over and we look, and I'll shift it if I can. Can't even really shift it much, but you can see on the inside of that hole it's not lined up. It doesn't technically line up that well, so we want to snug the front one down, and I mean snug it. Don't torque it, don't tweak it, don't literally just use your pinky and thumb. But don't give it any oomph yet. You literally just want metal to contact metal. And then we're going to get our other Allen. It goes in the piloted hole. And we're going to thread it down in here if our hands will cooperate today. We're going to thread it down into the hole where the pilot has been drilled into the barrel. And this is why we don't lock the other one down. There is a small amount of play, so we want to let that play work itself out. Gently wiggling it back and forth. Let the tapered seat of that Allen settle into the tapered seat of the pilot. And again, we're not oomping it. It's very gently seated in its hole. very gently seated without a hole. So now that's the tube applied, installed into the receiver. Inside the receiver where you can't see, because this is in place, I know it's gone in correctly. So what's happened is the tube has gone inside the gas tube extension on the top of the bolt carrier group. This is the correct fit. It should look like this. That hole should line up there. This should go down the tube firmly. You shouldn't have to play, wiggle, jiggle, or anything else. This is what you're looking for in your test fit, and this is what you're looking for in this initial assembly without any adhesives or any permanents to it. Everything has gone together easily without having to force anything. The only time I had to take a hammer out was to get the roll pin in, which is as intended because it is not a threaded fastener. It is considered a permanent fastener. So now we get our handguard on. We will move our other stuff, which we are not using currently, to the side. We will get our screws out for our handguard. And at this point I'm probably going to have to go get a different tool because I forgot these were Torx. I counted them out inside the bag, so I'll know if I lose one. Look at that. Tried to. 2, 4, 6, 8. I'm going to pause real quick to go get my Torx, and I'll be right back. So now I have my Torx bit on a T-handle driver. I'm going to insert that into the hole. Actually, you know what I'm going to do? I'm going to pull the bit, thread it in by hand. There's a possibility with the mass of the driver itself that it could wiggle at the wrong time and take out a thread. Small chance if you're careful, but it's like I explained to people who want to mount a bunch of stuff on their roof. It's a small chance that the hole you're making to install something, say a satellite antenna or solar panels on my roof, yes, you use good fasteners with seals, and they minimize the chance that something will leak through that hole you want to punch in my roof. Do you know what makes the chance of your hole in my roof, or a hole you want to punch in my roof, leak, as in reduces it to 0? Not having you punch holes in my roof. Same deal here. The chances of this big bulky tool throwing off the initial alignment of the screw into the hole is much lower if I don't have the big bulky tool there. You always want to start any threaded fastener into place with as little force as possible. This minimizes the chance of you messing up the threads while you're assembling it. Just like the guy with the barrel nut who grilled it down the very first time without doing a proper inspection. He screwed himself. Do not, in the case of handguards or anything like this, which has multiple fasteners around the perimeter, you don't fully tighten any single fastener at any point. You want to take all the fasteners, install them until they're just barely snug, and then possibly back them out just a hair, and that helps them seat up properly in their own proper position. Because here again, even though I'm dealing with Aero on Aero, yes, most likely the Aero Upper and the Aero handguard were both made in-house, possibly both in the same house. However, nothing is 100% precise. If you encounter a machinist who tells you he is 100% precise every time, bar none, 0 errors, you have just encountered what we like to call a liar. Avoid that individual. You might try to clarify in case he's just trying to pacify you by telling it's wonderful and perfect every time. But the fact of the matter is, nothing in any process is 100% perfect every single time. So what we do as the assembler or the quote-unquote builder is minimize the chances of something screwing up even worse because of a minor mistake made by someone else up the road who made a screw in China, firearms component in America, coated it in Mexico, and shipped it to your house via people who really don't care, and used it for a football before it got to your home. Because all we can do is work to minimize the problems. We can't prevent them all, we can't fix them all, but if we're very careful in our portion, then we have minimized the probability that something will be messed up by us. And there again, that's all we can do, because we're no more perfect than the machinist who lied about being perfect. So that's it. 8 screws, snug down, finger tight. Everything lined up, everything threaded up, and everything went in its proper place. We'll pull this back apart. I will apply blue Loctite to this and a couple other places, do my final assembly, and then we'll have a finished product. Just an FYI of advice, my blue Loctite is going to be installed in these screws and these 8 screws and nowhere else. Stay tuned. And I'm going to have to let the children back in the room to see the finished product, because now it's Christmas. See you in a minute. And that is why Tommy's mom is a really... okay, so the YouTube folks that I couldn't show how to actually do the assembly step by step are back. So this is the completed 6.8 SPC Aero Enhanced Upper with handguard, dead shot barrel, AR Stoner from Midway, gas block, gas tube, bolt carrier group, and charging handle. At least I believe the charging handle is AR Stoner because it looks cheap, and I buy my cheap stuff from Midway USA. So there it is. It is currently assembled. Mine is ready to shoot. If you do one that is a mismatch between the bolt and the barrel, I highly recommend having a professional gunsmith look at your headspace. I'm actually going to take mine down and have the headspace double checked, because I couldn't find a 6.8 SPC headspace gauge in my tools. So apparently I will also be doing the same thing. Haha, good job. This is why we go through our stuff and double check it before we get too nuts on these projects. So this is the completed unit, assembled. Screws have been torqued. Blue Loctite used on certain components, not used on others. Roll pins hammered in. Everything torqued down to manufacturer's specifications for the individual components in question. I did not actually use the armorer's wrench that I had in the video because, well, it didn't serve any purpose on this build. But the armorer's wrench is a nice handy little tool. You may use the little flat point if nothing else. This section here is for your lower, for the buffer tube. This area here would normally be your barrel nut. However, not on this one. Aero Precision uses a different spacing on its castle nuts. So the castle nuts are slightly different. I'll see if I can get it close enough to show you. So see how they're just a little bit off? They're not the same. They're not going to work. So you use Aero Precision's included tool to torque down your castle nut. I'm sure a lot of people who've possibly made it this far, and basically everyone who's clicked on it and said, F this is too long, was like, well, why did you do an inspection and then a test fit and then a test assembly and then a disassembly and then a reassembly and then a reassembly with torque, or another disassembly and then a reassembly with your torque specifications and all your other, you know, lubricants and additives and everything added in? Well, because I'm a little OCD. I'm I'm not going to say I've been doing this for a whole long time. I'm not going to say I'm the best at this, and I'm not going to say that there is necessarily any benefit that's going to make you shoot some MOA groups just by doing so many stages. What it will let you know is if you encounter a problem, or if during one of the stages you've lost something, or you didn't have something initially, like I forgot my charging handle. All these steps are in place to help you minimize the possibility of you effing up. They're not required. They're the way I do it, the way I recommend you do it, especially when you're doing it the first time. Get a feel for how the screws thread into the holes gently by hand so that you don't destroy the threading, because there are ways to repair the threads on this. However, any damage you do to it is going to be far more expensive than if you do no damage to it. Assemble it properly, double, triple check it, get it all put together, make sure you've done everything right. Assemble it onto a lower before you ever put a round in it. Cycle it multiple times, just by hand, exercising the action to make sure that you don't hear any grinding, feel any catches as it moves back and forth. If you encounter any problems when working it mechanically by hand, stop, disassemble it, take everything apart, look for pieces of metal that may have gotten caught up somewhere weird and goofy. I mean, all I can say is I have a review coming up where I purchased a new firearm and it had issues, and I disassembled it and reassembled it several times and never found the issue until one more time I went through. So what you always have to consider is give yourself a good chunk of undisrupted time. Take your time, get your own routine down, figure out what tools you need for what you have, and just go through it nice and slowly. Slow is smooth. Smooth is fast. Don't rush it. You don't rush the assembly any more than you rush the maintenance, any more than you rush the operation of a firearm. That's really all I have to say for this video. It's been a really long one. If you stuck around this long, hopefully you're like and subscribe. If you stuck around this long, hopefully you got some kind of information out of this. Hopefully if you stuck around this long, you enjoyed it. You'll watch some of my other videos, and we're going to go from here and see what we can get away with on and off YouTube, trying to educate people on the shooting sport in general, on reloading, on the tools, the gear, the components, the assembly. We're not manufacturing firearms, folks. We're assembling from parts provided from subcontractors. That's right. We're not a manufacturer. We're not modifying, we are assembling parts. That's what we're going to do here. That's what I'm going to do here, and what I want to show some of you folks how to do. The AR platform, it's the adult's plastic brick. There are just so many options with colors, components, and everything else, that if you enjoy the shooting sport and you want to try your hand at moving to the next step and assembling your own, or building your own, or whatever word you want to use for it, the AR-15 is probably a good place to start with trying to get into some unicorn calibers like this 6.8 or 300 black or 6mm arc, which is what I'll be doing later. We're going to do a 6 arc build. We're going to do a couple other builds and some weird goofy unicorn calibers that a lot of people don't shoot. But we're going to do it because I want to do it, and I'm funding this sucker until everybody likes and subscribes. And maybe one day Aero will send me a bunch of components and I can do a bunch of stuff on somebody else's dime. But this has been an assembly video, not a review video. This is the assembly of components that I have found that I enjoy over time, and there will be reviews of the individual stuff. And there will be links in the videos I review where you can go and purchase these components. But this has been a really super long video. Thanks everybody for bearing with me. Try to keep most of my stuff a little bit less dry, but this has definitely been drier than a popcorn fart and a lot longer than I intended. But if even one person gets good information out of this, I consider it my time and money well spent. Thanks a lot, folks. Adrenaline Fueled Firearms. I'm Scott, and I hope to see you again. Maybe even actually like see you again. You can look at my ugly face while you listen to my nasty voice. Thanks a lot. Take care. Happy shooting, safe shooting, and have a great day.